The phone number contains a country code and STD code and the phone number. Three values will be there. The same way, if you take your ration number contains the the location code, whether it is a main campus or SRC campus, and then it contains branch code, which branch you are studying, and it contains the pass out batch, which year you are passing out. After that, it contains your ration number, roll number. Okay, so this is what the subparts of your ration number. Now, your ration number is one example for composite data. The same way, we can say structure also a composite data. In C++, you may have studied about structure. Within structure, we can attach roll number, then name, then mark, all these things we can combine. So that is also one composite data. We can combine some meaningful data into a single entity. So this is atomic and composite. Now, what is a data type? We already know about, we studied about some primitive data types, integer, float, character. So what a data type expresses means it expresses the data and what are the operations that we can perform on the data. If it is an integer data, what are the operations we can perform? We can perform addition operation, subtraction operation, multiplication operation, division operation, module operation. If it is a float, in some programming languages, we cannot perform the module operation for float data type. If it is a character, you cannot divide a character by another character. There is no meaning. So, if it is a character data type means we can concatenate two characters. But adding of one character with another character is there is no meaning. So, what data type expresses? It expresses what type of data we can store, and also what are all the operations we can perform over the data. So, this is what a data type. Now, let us come to the data structure. What is a data structure? A data structure is an aggregation of atomic and composite data. So a data structure may contain atomic data and also composite data with set of defined relationship. How the first data is related to other data. Once we access the first data, how to access the next data, the accessing set, how to add data into the structure. Okay, we will have some set of rules which binds the data together. So this is what data structure. And a data structure can be nested also. Within one data structure, we can define some other data structure also. It is also possible. Some basic things. Okay. Next, let us take this example. Okay. Now, here, if you are looking means, I have created a list L1. Within L1, I am adding 10. L1 dot add of 10. L1 dot add of 20, L1 dot add of 50. I am adding some elements. Then I am calling L1 dot print, and then I am calling L1 dot remove. Now all these are functions which built over the data structure list. Now we are simply calling add. Internally, how this add function is working, whether this 10 is stored in an array or some other data structure. Why means a list can be created using a matrix format or a linear list format or a tree format or a graph format. You can store list of number using any of these structures. Which type of structure used within this list? We don't know. That is what ADT, hiding the implementation details. We are simply calling, if you want to store 10 within the list, call L1.add. That's it. Internally, the add, whether it is storing the 10 in a matrix format or a linear list format or a tree format or a graph format, we need not worry about it. Okay, creating such type of program is called as a ADT, abstract data type. It contains data and operations we can perform over the data encapsulated together is a ADT. And if we need to create it as a generic. Generic means if you are creating a list ADT, it should not be binded with one particular data type. Means integer list. It is not like that. If you're creating a list means it should allow us to process integer data also, string data also, and any other user defined data also. If you have a structure of a students, it should allow us to store student structure variables into it and retrieving. It should allow us like this. So it should be generic. So when you are creating a generic structure like this, then it is ADT, abstract data type. It is hiding the implementation details from the end user, end programmer. So this is what the basic idea of a ADT. Now, ADT consists of set of definition that allows programmers to use the functions while hiding the implementation. As I already told you, hiding the implementation is the main aim of abstract data types, ADTs. Now, let us take one more example, bank queue example. Suppose if a programmer is planning to automate the banking functionalities, okay, in bank, many people will come and stand in queue to get services. Now, whenever a customer comes into the bank, he should be added into a queue. Now we have two options. What are the two options means? We can create a queue specific to customer object and use it in our program. This is one solution. What is the other solution means? Creating the queue as a ADT and use the queue in our program. What is the advantage of the second one means? Once we created a queue ADT, it can be used in that bank program and also it can be used in any other program wherever we need queue operations. So that is what advantage of ADT, creating a generic data structure. So in this course, we are going to create ADT for all our data structures. Whatever the data structures we are going to create, all these data structures can be created as a ADT, list ADT, tree ADT, BST, binary search tree ADT, graph ADT, okay, and link stack ADT, queue ADT. All these data structures we are going to implement using the ADT concept. So once you are creating a stack, you can use it for integers and also for string and also for any other user defined types. So this is what the basic idea of abstract data type. Now let us come to the definition of ADT. So what is an ADT? An abstract data type is a data declaration packaged together with the operations that are meaningful for the data type. This is very important, meaningful for that data type. Okay, it is not like whatever we can add some data and whatever the operations we need to perform over the data, all the operations we can package together. It should be meaningful. We already study, I hope you already have some idea about stack. If you take stack, what are the operations allowed in stack means only push, pop, top, stack top. Only these are allowed. We can get the number of elements in the stack, count. These are all the 4 operations allowed in a stack. Okay, so the meaningful operations only we need to package with together with the data. So this is the definition for ADT, abstract data type. Okay, basically here what we are doing means we are encapsulating the data and operations together, more or less like writing our CPP class. In CPP class, what we are doing, we are declaring data and writing functions and encapsulating it into an object. Okay, so encapsulation is the major concept here. Okay, abstract data type, declaration of data, declaration of operations, and encapsulating the data and operations together. Now, any doubt so far? Whatever we discussed so far, any doubt? What is the ADT? Any doubt? If you have any doubt, you can tell me now. Any doubt so far? Okay, fine. Thank you. Next, we move to the ADT model. So this is what the general structure of any ADT model. whenever you are creating an ADT, the ADT may contain some data structures. It needs some data structures to store the data. Whatever the data we are going to store, it may be stored in an array, or it may be stored in a record or linked list, some data structures. Okay, all the ADTs will have some data structures like this, and then public functions, and then private functions. So what is the use of public function means? Only the public functions will be visible to the end user. Okay. So we already discussed about this list example. Here, add and print, remove, these are public functions. If you want to access the L1, means the list, we can access only through these public functions only. We cannot access any, we even don't know what all the private functions exist within the list. The private functions will be internally invoked by the public functions of the ADT. So all the ADTs will have some built-in data structures and private functions, public functions. The public, only the public functions are visible to the application programmer or any other end user. So the application programmer will invoke the public functions to store the data, retrieve the data, or manipulate the data. And very important thing is all these things is happening dynamically. So dynamic memory allocation concept. So whenever you are adding 10, memory for the 10 will be allocated dynamically. See here. First I am adding 10, memory will be allocated. Then I am adding 20, memory will be allocated dynamically. Then I am adding 50, memory will be allocated dynamically. So dynamic memory allocation also here, it plays a important role. Now in ADT, as I already told, these two things are important: ADT operations and ADT data structures. What data structures internally used? Based on that, the efficiency of the ADT will be improved or decreased. The ADT operations. What are all the operations that are public, visible to the application programmer? So this is the general ADT model. Whenever we are creating any ADT, it should follow this model only. Now, let us take one example. So, ADT list implementation, linked list implementation. Okay. So, a list can be implemented using arrays or linked list. Okay. If you want to store list of numbers or list of products or list of students, any list, if you want to maintain means, you can easily go for array concept. So, array of 10 numbers, array of 10 students, array of 10 products. Simple. We can store the values in the array, we can retrieve it, we can access one after another, we can perform sorting operation, everything we can perform. Yesterday itself we discussed about the disadvantage of this array implementation. Okay, accessing an element is very fast, very quick in arrays, but inserting a new element into the array, that is difficult. The same way, removing an element also difficult in the array concept. So what we need, what we can do means, instead of array implementation, we can go for linked list implementation. Okay. So what is this linked list? A linked list is an ordered collection of data in which each element contains location of the next element or next elements. So that is what a linked list. See here. Now the first picture, a linear list. Here, check it. Each node, okay, we call this as a node. Each node contains data and link part. The data part contains the values and the link part contains the address of the another node. So here each node can be created in different memory locations. Since we are using the dynamic memory allocation concept, whenever you are calling the dynamic memory allocation, the memory will be allocated in different paths. So the memory is not sequential. If you take the concept of arrays, in arrays, memory will be allocated sequentially. So we can access it easily. But here, since each node is created in different memory location, we need a certain way to access all the nodes. So that's why here we are storing address of each node in its predecessor node. So just 1 minute. Okay, so the address of each node will be stored in the predecessor node. Then only it's possible to access each node till the last node. So this is what linked list. So a linked list can have the address of the next node. Okay, only one node, or it may be it may contain two or more addresses also. So when we will use the two or more addresses means suppose if we are going to implement a non-linear list. When we are implementing non-linear list, each node will have two or more links and then empty list. So this is what linked list, the idea of a linked list. Okay, so a linked list is an ordered collection of data in which each element contains a location, the location of a next element, and also it contains the data. Okay, so in linked list, each element contains two parts. The first part is a data part and the second part is a link part. The data part holds the data. The data may be a single atomic data, or it may be a composite data, or it may be a structured data, anything. Okay, data you can store even the object of a class also. Okay, and links are used to chain the data together. After visiting one node, to move to the next node, we need the address of the next node. So that will be stored in the predecessor node. So they contain pointers that identify the next element in the list. The major advantage of a linked list is compared to arrays concept, it is very easy to perform the inserting a new element and deleting the element. We need not move the data elements or create an empty room for like in arrays concept. So inserting and deleting elements in a linked list is very easy. So wherever whatever the location, we need to perform more addition and deletion operations in such list. Such kind of lists can be implemented using linked list concept than array concept. So this is a linked list implementation. So here what we are doing means we are discussing about ADT list. Okay, how to create ADT for list, the general idea. So a list ADT for list can be implemented using array and also using linked list. We have some disadvantage of arrays concept, so we are discussing about a linked list implementation concept. So in linked list, we have node structure. What is a node means? It is a structure that has two parts, the data part and link part. Okay, and the nodes are called as the nodes are implemented using self-referential structure. What is self-referential structure means? It contains address of the same type. Okay, a self-referential structure, each instance of the structure contains one or more pointers to the other instances of the same structure type. Okay, self-referential. So a node of one type can point to the same type of another node. Okay, so this is what self-referential structures. Now, a linked list must always have a head pointer. So what is the purpose of this head pointer means? A head pointer will point to the first node in the linked list. So it has address of the first node. Okay, so based on our implementation, we can have other supporting node structures also. Okay. Now, let us discuss about some example node structures, how to write it in C program. Now, normally we know structure concept in C. Okay, using structures we can create a node. Let us see the code for that. Now check this notepad file. Now here the node structures can be created these ways. Okay, the first one, it is a structure node. Okay, it contains only one integer data, int data, and struct node star next. So this is what called as a self-referential structure. Okay, so it is storing the next to this variable. It is storing address of the same type of structure variable. Okay, for structure variable, if you are creating a other one more node means its address we can store it here. So n1, n2, n3, n4, like that. If you are creating structure variables, then n2's address in n1 and n3's address in n2 and n4's address in n3 and n4's next we can make it as a null since it is the last node. So this is the first type of node. Okay, if you want to store only one integer data, we can create this kind of structures. So we can create the other type also. Here what I'm doing means instead of storing simply one integer, I'm storing details of one student. So integer roll number, character array of characters, name, and float CGPA. And after that I'm having the struct node star next. Okay, so self referential structure I am creating this. So this is other way. What is the one more way means we can create a student structure separately, struct student, integer roll number, name, CGPA, and then we can create variable for the student structure within the node. See here, struct node, struct student s, struct node star next. So these are all the different ways of creating node structures. So when we are implementing the linked list concept in C, we will dynamically create these structure variables and attach one variable with another variable. Finally, we will get one list of nodes. We can add new node into the list. We can traverse the entire list. We can perform the searching operation. Everything we can do. How we are inserting, how we are adding and searching values in an array. The same way we can do it in the linked list also. The linked list implementation we will see in the further chapters. Okay, here one student asked doubt why can't linked list stored sequentially? So why we cannot store linked list sequentially means whenever we are creating a linked list, so we will call the dynamic memory allocation function. So when you are calling a dynamic memory allocation function, it is, we cannot make sure that the memory is allocated adjacent to the already created memory. So it is not in dynamic allocation, it is not possible to ensure the first created dynamic memory and the second created dynamic memory both are adjacent with one another. It is not possible. So linked list, for each node, we cannot create memory sequentially. Sai Sudarshan, I hope I answered your question. And regarding the textbook, some students are keep on asking. In Google, it is available. The book is available. In Google Classroom, I posted only the link to Flipkart and Amazon. Okay, so if you're checking Google, in Google, the PDF version of the book is available. You can download it and you can share among yourself. It is available. Sir, reduce the font size. That I'll do it in the next class onwards. Okay, fine. Now we'll move to the next concept. Okay. So this is what we discussed in the notepad, the syntax for creating a node with the data alone, creating a node with data means a composite data like a name, ID, and grade points, and then keeping a structure variable inside the node structure. So this we discussed in the with this we have seen in the examples. Okay, now this algorithm efficiency part. Okay, this algorithm efficiency part, it is actually not included in your syllabus, but it is better to know about the calculating the algorithm efficiency. This is very important part. Okay, why it is not included means you are going to study the design and analysis of algorithm as a separate course. So in that you will study in detail about the finding the algorithm efficiency. Here we will study some basics of algorithm efficiency. Okay, why we need to study algorithm efficiency means when we have more than there are always more than one way to solve a problem. So in such case, for same problem, we will write more than one algorithms. Then how to choose which algorithm is efficient one, which algorithm is best one. Always the efficiency will be calculated based on the time and space, how much time one algorithm takes and how much memory space one algorithm takes. Based on that only efficiency will be mostly calculated. Here we have the domain called algorithmics. Okay, what is algorithmics means? It is a systematic study of the fundamental techniques used to design and analyze efficient algorithm. Always the efficiency of an algorithm can be expressed like this: f of n equal to its efficiency. Okay, normally when we have normal steps, input statement or assignment statements or arithmetic statements, simple statements, it will not affect the efficiency of an algorithm, because in all the algorithms these concepts will be there. Mostly the efficiency of an algorithm will be disturbed by the iterative statements. Okay, so how much time it takes to complete an iteration. So we should not make any mistake in the iterations. How much iterations are actually required, one based on that only we need to give the condition. That is important. So here in the basic concepts, we are going to study about what are the different types of loops and how much time it will take. The first type of loop is linear loops. See here, linear loops means it will execute linearly. Okay, now how a number of based on the count variable, its efficiency also equal to the n. So if you take the first example here, the first for loop will execute 1000 times, so its efficiency is n, 1000. F of n equal to f of 1000 equal 1000 efficiency. The second loop it will execute only 500 times and its efficiency is n by 2. Its growth will be linear. If the number of if the n value increases, then the efficiency also increases. If the n value decreases, then the efficiency also decreases. So this is what linear loops and their efficiency. The next is logarithmic loops. In linear loop, the increment and decrement will happen, means the I value will be incremented or decremented. But in logarithmic loops, the for loop variable will be either multiplied or subtracted. So the growth of the efficiency will be in logarithmic. So here the multiply loop and divide loop. See here, I is divided by 2 every time, each iteration. So in this case, f of n equal to log n efficiency. Okay, and then we have nested loops. So nested loops, if you are taking, means within means writing the for loop within another for loop. How to calculate efficiency of this nested loops means we need to multiply the efficiency of the inner loop and efficiency of the outer loop. Then we will get the total efficiency. So linear logarithmic, the outer loop is a linear and inner loop is a logarithmic in the first example. So its efficiency is a n log n. Quadratic means okay, the inner for loop also linear and outer for loop also linear. So we need to multiply. So multiplying means n into n square. F of n equal to n square. Dependent quadratic. Dependent quadratic means the inner loop will be executed based on the value of the outer loop. So here it is n into n plus 1 by 2. Okay. This is the general things. Mostly whenever we are discussing about efficiency of an algorithm, we will use the term called big O notation. So what is this big O notation means? When comparing two algorithms, each and every step we need not consider. Only a particular part of the algorithm will make more difference in its efficiency. So what is that particular part? What is it? That particular dominant factor. Calculating the dominant factor is a big O notation. Normally, if an algorithm contains more than one efficiency steps, how to calculate the big O means we need to follow the steps. First, what we need to do means we need to write all the efficiency values in that algorithm from sorted order, lower to higher. Okay. After writing it, we need to remove the coefficients of all the coefficients. After removing the coefficients, we need to remove all the smaller factors. Finally, we will get the big O notation of means the efficiency of the algorithm. Big O notation. Okay, here in this example, if you are taking means here f of n is given, means f of n is given as a n into n plus 1 by 2. If you are writing it properly, we will get n square by 2 and n by 2. First step, remove the coefficients. The half will be removed from n square and n. So we will get n2 plus n. After removing the smaller factor, n square and n, smaller factor is n. So after removing it, we will get n square. So n square is the O of n square. We will write the big O notation using O of n square. So this is what the efficiency of this algorithm. Now try to calculate efficiency for this one f of n, this algorithm. Okay, so for this, what is the algorithm efficiency? Try to calculate it. Yes, correct. O of n power k is the largest term, so that is the result. Very good. First removing the coefficients. After removing the coefficients, we need to remove the small factors, and finally O of n power k is the answer. Okay. Now so this is how we need to calculate the efficiency of algorithm. It's the algorithm efficiency. Okay. Now these are the summary. Okay, whatever we discussed so far in today's class, in yesterday's class and today's class. Okay. So what is a pseudocode? So in this PPT, I will upload it in the classroom. You can go through this PPT. Okay. In tomorrow's class, what we are going to discuss means we are going to discuss about recursive functions. Okay. What is a recursion? How to write recursive algorithm and how to solve the problems using recursion. So that is what we are going to discuss in the tomorrow's class. Okay. So this is yesterday's PPT. Okay, here we discussed about introduction and pseudocode. Today we cover the ADT and ADT model, ADT implementations. Okay, and tomorrow's class we are going to discuss about recursion. Once recursion is over, then we searching and sorting techniques we are going to discuss. Searching and sorting, many programs you might have implemented in the C and C++. The same here also. Okay, binary search and sequential search in searching techniques. Only two searching techniques we are going to discuss, and sorting techniques. Only two sorting techniques: bubble sort and in selection sort. Only two sorting techniques we are going to discuss here. Okay, and applications. Okay, recursion. What are the we have the application like how to solve the GCD problem using recursion, factorial using recursion, Fibonacci using recursion, then prefix to postfix conversion using recursion. These applications we are going to discuss. Okay, and this student information system using general linked list. So this we will discuss after the second unit only. Okay, so this is what our content for today's class. Okay, if you have any doubt in today's class, you can post it here. And one more thing regarding the textbook is please search in Google. You will get PDF book. Okay, it is available in the Google. Okay, you can download it. Okay, otherwise I will share it in the classroom. The PDF file I'll share it in the classroom. Any doubt in today's class? Sai Sudarshan, array and linked list occupy same amount of memory. No, actually, the linked list will take some amount, some more memory, because in each element we are storing the address of the next element also. So it takes some amount of memory. In array, no need of this, because array the memory will be sequentially allocated. So we know that the next element is available in the next memory location. So by incrementing the index value of an array, we can easily access the next element. But in linked list concept, it is not like that. We don't know where the next element exists or it is stored. So we are storing each element's address in the predecessor. So each node has data part and also address part. So comparatively, the address part, the linked list will take some amount of memory more than array implementation. And you can say that, sir, if array is taking less memory, then it is only efficient. Linked list is not efficient. Please don't think like that. Why means, okay, so based on our requirement, we need to choose the data structure. Okay, so suppose in our program, in our application, we are going to perform more addition, deletion operations. Okay, then choosing an array is not a wise idea. Okay, suppose in our program we are going to simply load all the data only once and perform simply accessing the element only. That is the operation we are going to perform means. Then compared to linked list, array is better. That's why we are going to study these many data structures: arrays, linked list, stack, queue, trees, all these data structures. It is not like all these data structures can be used in all the applications. Based on our requirement, we need to choose the data structure. That is very important. Big O notation, there are any rules or conditions to satisfy? Okay, it is not like conditions to satisfy. Once you created the algorithm, we need to check how many loops are there, and for each loop, what is the efficiency? First, we need to list out all those efficiencies. Then we need to apply the steps to find the big O notation of that particular algorithm. Whatever we are doing it in array, everything is possible in linked list also. Sumaya, searching not possible in list. Searching in linked list, we can do searching, okay, and updating the already existing value, adding a new value, deleting a value, whatever means all these are possible in linked list. We will see the implementations, C code implementation and CPP code implementation. In the second unit, we will show the demo and you can practice it. Kirtana, normal list is different from ADT. Okay, here I don't know what you mean by normal list. Okay, so normally whenever we are discussing about list will contain mostly homogeneous type of element. So list of numbers means it contains all the numbers. List of students means it contains all the student details. Okay, what is the ADT means? It is like a library function. Once you created that library, using that library, you can create integer list also, you can create student list also, you can create product list also, any list. So the list which is not binded with any specific data type is a ADT. So abstract data type means it should not stick with one particular data type. We will see how to create ADTs. Kirtana? Like head pointer, any other pointer to mark end of the list. As I already told you, based on our requirement, we can have it. Okay, if it is a linked list, okay, so singly linked list. Normally, all the linked list are singly linked list. So how to find the last node of the list means it will have the null value in the next part. Okay, the address part of the last node will be null. So while searching, in that way we can identify the last node. Suppose if we need if we have the doubly linked list concept. What is doubly linked list means? It is possible to move forward and also move backward. Each node will have two addresses, means the address of the next node and the address of the predecessor node. So in such case, we have the head pointer and also the end pointer. So if you want to print a list from back to front means using the end pointer directly you can go to the last node, and from there you can traverse to the head node. So it will print the list in reverse order. So in doubly linked list concept, we will use the pointer for the end of the list. Please explain slowly, sir. Okay, I'll now from next class onwards I'll try to explain slowly. Okay, fine. So I hope today's class went well. Okay, all the best. We'll meet in the next class. Next class we'll discuss about the recursion concept. You can leave now. Thank you.